Very good morning, students. Today my topic is the relation between molecular formula and empirical formula. Before that, I wanted to recapitulate the previous topics which I have explained you. You can say molarity, normality, mole fraction, mass percentage, volume percentage, and all that. So I hope you are very clear in that part. And the very important area which we try to cover today is the relation between molecular formula and empirical formula. Anyone tell me what is molecular formula? If I write here water, right? I write benzene. What is the formula of the benzene? C6H6. So what is the molecular formula? The formula is said to be molecular if the atoms of the various elements gives the actual ratio. What is the actual ratio? Hydrogen is how much times here? 2:1. Oxygen is 1. Similarly here, in case of benzene, 6:6. Actual ratio of the atoms. Carbon 6 times and hydrogen 1 times. Therefore, molecular formula is very simple. It gives the actual ratio of the atoms of the various elements. Like benzene, C6H6, like glucose, C6H12O6. If I say glucose, C6H12O6, what is the actual ratio? 6:12:6. If I write here, it is the glucose, it is the benzene, it is the water, right? If I say it is the acetic acid, what is the formula of the acetic acid? CH3COOH, or I can write here C2H4O2, right? So if I say lactic acid, that is the CH3CHOH, or I can make it brief. Carbon how many times? 1, 2 and 3. C3H6O3. If I say diborane, B2H6. If I say ammonia, what is the formula of the ammonia? NH3. Like this. If I say the formula of the sucrose is, dear students, it is what? C12H22O11. The formula which I have written on the board is the molecular formula. So molecular formula gives actual ratio of the atoms of the various element. But dear students, what is the empirical formula? Simplest ratio of the atoms of the various elements. So empirical formula provides simplest ratio of the atoms of the various element. If we want to say further, water, what is the molecular formula? H2O. What is the actual ratio of the hydrogen and oxygen? 2:1. Similarly in glucose, 6 carbon, 12 hydrogen and oxygen 6. Similarly in acetic acid, right, like this CH3COOH, make it short, C2H4O2. Lactic acid, C3H6O3, like diborane, B2H6, ammonia, and so on. So these are the molecular formula. If I want to express in the form of the simplest ratio, simpler and simplest. For example, if I say what is the formula, actual simplest ratio of, you can say water. So now I write here empirical formula. So oxygen is already 1 and hydrogen is 2. So it is the same formula. This is the H2O, because of we cannot get the simplest ratio than the 1. 1 is the last. If you don't get any figure to cut to form the simplest ratio, then you apply 1. If you are taken 1, then molecular will be same as the empirical formula. But here in case of the benzene, if I want to divide 6, then it is the C ratio H. that is the CH is the empirical formula of what? Benzene. And in the glucose, if I divide it by 2, then its formula is now CH2O, 1:2:1, because of in denominator I have taken, I have taken here it is the 6, and 6 cancelled out, then 12 is 2 times and 6 is 1 times. So glucose has molecular formula C6H12O6, but its empirical formula is CH2O. Just like acetic acid, if I want to divide it by 2, then again it is the CH2O. If it is the lactic acid, I want to divide it by 3, then it is again the CH2O. Diborane, what is the empirical formula? BH3. But so far as ammonia is concerned, same formula as the molecular and empirical formula. So far as sucrose is concerned, it is not going to cut by any figure, so therefore it will remain same, C12H22O11. So dear students, these are the empirical formula of the glucose: CH2O, CH2O, acetic acid and lactic acid. We observe that many more compounds possess the same empirical formula, but they have different molecular formula. As such, empirical formula has no practical significance. No practical significance as such, because of few compounds like glucose, acetic acid, lactic acid, even they have different molecular formula, but they have the same, empirical formula. That is why practically it is insignificant. Generally we talk in class the molecular formula. So I hope it is clear to everyone. Okay, may I proceed to have the relation between molecular and empirical formula? Dear students, can you tell me what is the equation? Molecular formula is equal to N into empirical formula. It is the equation 1. What is N there? Where N is the multiplying coefficient or multiplying factor. That could be 1, 2, 3 and so on. So N is the suitable multiplying coefficient, suitable multiplying figure. That is, if you want to take N out, then molecular formula divided by what formula? That means you can say molecular formula mass upon what is that? Empirical formula. Every formula has mass. Molecular formula mass divided by empirical formula mass. In that way, if N is equal to 1 after the division, then molecular formula should be equal to what formula? Empirical formula. If N is not equal to 1, then obviously molecular formula should not be equal to what formula? Empirical formula. So as such, I give you one example here. Glucose. Find the relation. Find the relation between molecular formula and empirical formula of what is that? Glucose. So what is the molecular formula mass of glucose? Mass of glucose, you know it, molar mass, C6H12O6. 12 into 6 plus 1 into 12 plus 16 into 6, that is equal to 180 AMU, or you can say unified mass. Anyone you can write here. So now you write the empirical formula mass of glucose. So what is the empirical formula of the glucose? CH2O. So its mass is 30 unified mass. Right now, because of empirical is CH2O. Carbon 12, hydrogen 1 into 2 plus oxygen 16 into 1, 30. So if N, we want to calculate N, therefore molecular formula mass divided by empirical formula mass. What is the result here? May I have this part? It's alright? Okay. So dear students, N equal to molecular formula mass is 180 of the glucose and empirical formula mass is this one. So what is your answer? N is 6. Put 6 in equation 1. So molecular formula is equal to 6 into CH2O. that means C6H12O6. The way you can solve, I give you a question, find the relation between molecular and empirical formula of benzene. You know it. What is the molecular formula of the benzene? C6H6. And what is the empirical formula? Yes, CH. So the molar mass of benzene 12 into 6 plus 1 into 6, 78, and empirical formula CH 12 plus 1, 13. 78 upon 13, n becomes 6. Put the value of n in equation 1, the way you can get the molecular formula. So dear students, it is a very theoretical part of the molecular and empirical formula, but the very important part is how to solve the numerical based on molecular, based on the percentage composition. Right now. So dear students, if I give you a question, question is find empirical formula and molecular formula of oxide of iron if iron is 69.9% and oxygen equal to 30.1%. So if the percentage is given, then first of all we have to find whether it is 100% or not. If the composition is 100%, then it's all right. If it is not, if it becomes 80% iron and chlorine and whatever it is, then you have to add oxygen so that the deficiency can be overcome by adding oxygen. It is assumed that oxygen forms many more compounds as compared to the other element. Therefore, it is suggested to carry the oxygen so that deficiency can be overcome by taking the rest of the amount with the help of oxygen. In this case, oxygen is already given. So iron and oxygen, it is 100%. It's all right. But if I give you sodium, sulfur and chlorine, right, then if it becomes total 90%, that means the deficiency is the 10. Therefore, you have to add oxygen is equal to 10, so that you have to get it 100% always. So there is a substantial difference is there, not difference by 2, 3, 1 and all. If difference maybe 10, 12, 15, obviously then you have to add the oxygen. You will get the numerical like this. But here, if you want to calculate the molecular formula, then you have to calculate first what formula? Empirical formula. If this time, if I find the empirical formula and I delete the molecular formula, suppose find the empirical formula of oxide of iron, then iron is given and oxygen is given, right? If I want to calculate the empirical and molecular formula, so dear students, you have to calculate first empirical formula, right? No? So to get the formula, first of all you have to prepare a table like element, percentage, atomic mass, atomic ratio, simplest ratio and simple whole number ratio. Element percentage is given here, the data element given, percentage given, even atomic mass given, but you are supposed to remember the atomic mass from hydrogen to zinc. Atomic ratio, then you divide it. For example, it is the question based on the oxide of the iron. Iron is how much here? Iron is 69.9. So here write iron and oxygen, right? Make the table like this: 69.9, 30.1. What is the atomic mass of the iron? 56 and oxygen 16. So the ratio 69.9 divided by 56, 30.1 divided by 16. Whatever the ratio, you will get it, and then the lowest factor which the data which I would like to share. Because of this numerical part you can solve yourself. 69.9 divided by 56, that means it is the 1.25, and this is the 1.88, like this. Dear students, this division is 1.25, which is the lowest factor, 1.25. So divide it to all. 1.25 divided by 1.25, it is the 1. Or 1.88 divided by 1.25, it is approximately 1.5. Then the final is the very important simplest whole number ratio. So near to the precise values we have to collect. Right? If we are getting 1, it's all right, it is the 1. But if you get 1.5, tell me anybody, what is the simple whole number ratio here? So if we will get here 1.25, you remember it, 1.33, 1.50 or 5, 1.66 or 2.66. You will get this value here in the simplest ratio. You have to make a table. If I have to get the simple whole number ratio of the 1.25, then you have to multiply 1.25 into 4. Exactly you will get 5 answers. Because if we multiply 3, then it is 3.75. It is far away from the simplest ratio. Therefore, you have to go for the closest precise values. Therefore, 1.25 whenever multiply, we get the exact 5. So 1.33 multiply by 3, 3.99, you can take 4. 1.5, if this time we have 1.5. Now tell me, 1.5 to be multiplied by 3, this is the 3.0. 1.66 multiplied by, this is the 3. Then 6 3 are 8, 9 and 3 1 are 4.98. That becomes the 5. Or 2.63, 7.98, you can take 8. You will get frequently, you will face 1.25, 1.33, 1.5, 1.66, 2.66, like this factor. And the way you can calculate you can see the value is here 1.5. So we have to multiply by 2. What is your answer? 3.0. In the same way, we have to multiply here again 2. This is the 2. So right answer is, the empirical formula is iron 2 times and oxygen 3 times. Therefore your answer is Fe2O3 is the empirical formula. So it is very easy to calculate the empirical formula. Percentage given, you know the atomic mass, and then you can divide the atomic ratio, simplest ratio and simple whole number ratio. Now if I add empirical formula and what formula? Molecular formula of oxide of iron, if iron is this, and the molecular mass is 159 is given to you. It is provided in the question. If you want to get the molecular formula, first you calculate the empirical formula. Then in question, molecular mass must be given. If molecular mass not given, then what given? Then to get molar mass, if it is given, it's all right. If not given, then molar mass is equal to 2 into vapor density. Whatever the vapor density given, multiply 2 into vapor density, you will get the molar mass. Because why molar mass is supposed to be given? Because of molecular formula is equal to N into empirical formula. So if you want to get the value of N, the molecular formula mass upon empirical formula mass. What is the molecular formula mass? It is you can say 159, and hopefully you can see empirical formula mass is same because Fe2O3 is here. So 159 approximately 56 into 2 plus 16 into 3, that means 56 into 3, 12 plus 48, 8 to 10, 415, and then 159.5 whatever it is, because of the whatever it is given like this 159.5 and all. So here answer is, what is that? 1. This is what, because of if I take 55 point something, then it becomes round about 158 point whatever it is. So there are students here, so the 159.5 or 159, we can take 160 divided by 160, so answer is 1. So the way molecular formula is equal to n into empirical formula, 1 into Fe2O3, your answer is once again Fe2O3. So to get the molecular formula, molar mass is given. If mass is not given, molar mass, I mean to say, then therefore density is given, because to get the n you need the molar mass, because you already obtained the empirical formula. So the way you can calculate the empirical formula mass, right? So can you solve a question based on the molecular and empirical formula? Okay, so write down, solve a question. Here, is it clear to everyone? Need to go through that. Need to give you a small pause and just to click down and write down to your own words, and let you solve the other question. Now dear students, I give you the ratio between the various elements. You can say question is calculate molecular formula if molar mass is 160 from the data given. What the data given? You can see here. See, this is the calculate the empirical and molecular formula if molecular mass is given 98.5. Sorry, here you have to write 98.5 from the data given. Molecular formula हमें निकालना है. So to get the molecular formula, what I have told you, I given you a piece of advice to carry the empirical formula. For empirical formula, you have to draw the table. Here you write down element, percentage, atomic mass, atomic ratio, simplest ratio, and simple whole number ratio. Right now, let you go through the question. What the question is, I just read the data. I mean to say, the question is, carbon is 24.27, carbon, hydrogen and chlorine. This is the 24.27, hydrogen is 4.07 and chlorine is 71.65. My dear students, what is the atomic mass of the carbon? Yes, 12, hydrogen 1 and chlorine 35.5. What is the ratio? Ratio is, let you divide 24.27 divided by 12. This is your numerical part, so you can solve yourself, because in CBSE calculator is not allowed. 35.5 equal to 1. Is it clear to you? That is your area to divide all that. Because of this time I help you here. This is the 2, 4, 2. This is the 2, approximately 4, and this is the 2. 2 point something, 2.0 and all that, you can take 2, 4 and 2. What is the lowest factor? 2. So let you divide, simplest ratio, 2 by 2 equal to 1, 4 by 2 equal to 2, 2 by 2 equal to 1. So that means it is already the simple whole number ratio. So work becomes very easier. So my dear students, so what is that? Empirical formula, tell me anyone? Carbon 1, hydrogen 2 and chlorine 1, CH2Cl. It's all right. What is the empirical formula? Mass. Because I have to calculate the mass. Why? Reason behind is you have to calculate the molecular formula. So carbon is the 12 plus 2, 35.5. My dear student, 14.5 and 314, 49.5. So N is equal to molecular formula mass upon what? Empirical formula mass. So what is the molecular formula mass? 98.5 already given. If not given, vapor density is given. If vapor density is given, multiply by 2, you will get the molecular mass. Dear students, here 98.5 upon 49.5, approximately you will get the 2. So it is your empirical formula, multiply by 2. So molecular formula is equal to 2 into CH2Cl, C2H4 and Cl2. Let you see it. So I hope you can, if the percentage composition is given, iron oxide case very much explained in your NCERT book. 2 questions in your exercise. First you calculate the empirical formula and again you calculate the molecular formula, subject to provide the molar mass of that particular compound. It's alright. So the way you can calculate, this is all about molecular and empirical formula. One thing, the very small part, most probably you have done in your previous class, is the average atomic mass. Right now, average atomic mass is equal to percentage abundance. This is very little area in your syllabus, but one question is given in your book. Say for example, chlorine has 2 isotopes, chlorine 35 and chlorine 37. Its percentage abundance equal to 75% and it is the 25%. So how can you calculate the average atomic mass? This atomic mass is 35 of that element to be multiplied by 75 plus this is the 37 multiplied by 25 and sum of their abundance 75 plus 25. After solution you will get 3550 upon 100, 35.5. So what is the average atomic mass of chlorine? This is the 35.5. Those elements which exist in the isotopic forms, they must possess average atomic mass. And during the numerical, we cannot change 35.5 equal to 36. No, it is average atomic mass. So the way you can calculate in the other way, if it is the 75%, that means 3 parts. If it is the 25%, that is taken as what part? 1 part. So average atomic mass equal to 35 into 3 plus 37 into what? 1 divided by 3 plus 1. This is the 105 plus 35 divided by 4, 142 by 4, 35.5 is the answer. But if percentage given, then you can take the proper factor in the proper ratios, whatever given, the way you can calculate average atomic mass. So I change this question. I give you the other question. My dear students, solve this. Write down. Boron has 2 isotopes, boron 10 and boron 11. Right. Boron has 2 isotopes. One is the 10 and boron exists in 11. Its average atomic mass is 10.81. Calculate their percentage abundance. So average atomic mass equal to percentage abundance. I have already written. So average atomic mass is equal to percentage abundance. Here average atomic mass is 10.81. So let boron 10 equal to X percent and boron 11 is equal to 100 minus X percent. So 10X upon 100 plus 11 into 100 minus X upon 100 is equal to what is that? 10 point what? 81. boron 10 is the x percent, boron 11 100 minus x, so 11 to be multiplied by 100 minus x divided by 100 because you have taken in percentage, and average atomic mass is 10.81. You need to take the LCM, my dear students here. So therefore it is the 100 LCM, 10x plus 1100 minus 11x equal to what is that? 10.81. So to overcome this point, it is the 100 cancel out. So 10x plus 1100 minus 11x is equal to 1081. 10x minus 11x is equal to 1081 minus 1100 minus x is equal to minus 19. So dear student, x is equal to minus cancelled out. 98% is the boron 10. 19% is the boron 10. Then what about the boron 11? Boron 11 is equal to 100 minus 19, that means 81%. So let you go through that. Boron 10x, boron 11, 100 minus x. Let you go for that. It is given to you. And then you can calculate. What is that? Percentage abundance. If I give you the other question, let you solve. Copper has two isotopes. Copper 63 and copper 65. Copper 63 and copper 65. Its average atomic mass is 63.50. Then calculate their percentage abundance. In the same way, you can solve this question. Right now, so this is all about the molecular formula, empirical formula, and how to get the percentage abundance.